So here we want to balance this chemical equation, and instead of just trying to plug and chug numbers, hopefully that we'd be able to get the solution that way. We're going to be using some linear algebra. So we're going to be using matrices to obtain our solution. And if you're not familiar with matrices that often, or if you haven't taken linear algebra, I'll try to make this as friendly as possible to those who aren't familiar with matrices that often. So yeah, let's just get right into trying to solve this real quick. So we do know that we're gonna have some number for each of these. So what we're gonna do is, instead of putting numbers in front and just trying to guess, we're just gonna label them as A, B, C, and D. So these are the unknowns that we're trying to solve for in the end. And what we could do, or the reason why we're doing this, why we're just labeling them A, B, C, and D, is that we're gonna obtain a system of equations, and with that system of equations, we're able to create a matrix. And later on, I'll show you how to deal with that matrix to solve for this equation, or to solve for this chemical equation. So first thing that we're gonna do is we're gonna note how many elements that we have in this chemical equation. So here we have barium, so we're just gonna jot down Ba, that's 1. We also have nitrogen, we also have hydrogen, and we have oxygen. Now, we know that the amount for each of these elements, we know that the amount of that element on the left side has to be equal to the amount of that element on the right side. So if we treat this arrow like an equal sign, and let's take, for example, barium, we could see how on the left we have 3 times A bariums on the left side, and we have this equal sign. So we have 3A is going to be equal to C bariums on the right side. So that's already our first equation that we're going to be using to do this, to get our matrix, pretty much. And we're going to do the same thing for the other elements. So here we see that we have 2A nitrogens. So we have 2A, and that's going to be equal to, it looks like, D nitrogens on the right side. We do the same thing for the hydrogens. Here it looks like we have 2B hydrogens on the left, and on the right we have 2C. So 2C hydrogens for this part, plus 3D hydrogens for this part right here. So we have that, and now we have our oxygens to deal with. So we have B oxygens on the left side, and on the right side it looks like we have 2C oxygens. Okay, so now that we have our system of equations, so this is pretty much our step 1. Step 2 is we take everything and put it to the left side of the equal sign. So here is step 2. So for this one, we're gonna for the barium equation, we're gonna subtract both sides by C. So now we have 3A minus C, and that's gonna be equal to 0. And then we have our nitrogen. We're gonna do the same thing. So 2A minus D, that's gonna be equal to 0. And for hydrogen, do the same thing. So 2B minus 2C minus 3D is equal to 0. And now we have B minus 2C, and that's also going to be equal to 0. Now at this point, what we could do is create our matrix. So this is how we're going to create our matrix. So we take a look at how many unknowns that we have. So it looks like we have 1, 2, 3, 4 unknowns. And that's going to correspond to every column, or to each column of our matrix. So here I'm just going to label A, B, C, and D. And depending on how many equations we have, that's going to correspond to how many rows we're going to have. So we have 4 equations, so we're gonna have 4 rows, and thus we're gonna have a 4x4 matrix. And for each row, we're gonna put the amount of how many of that letter we have for that specific equation. So let's just take this equation for example, this first one. So for this first one, we have 3 A's. So we look at the column, we have 3 A's. We have no B's, so for this one, we're just gonna keep it as a 0. And then C's, we have -1 C's, and then we have 0 D's. Simple as that. So that's already the first row of our matrix. And then we just do the same thing for the other equations. So we see we have 2A right here. Let me just draw that like a bit more. That we have 2A, and we also have -1 of D. And then the rest are just gonna be 0. For this one, looks like we have 2B, then we have -2C, then we have -3D, and we have 0 A's. And now, same thing for the last one, we have 1, -2, 0, 0. So here is the matrix that we want. So this is our step 3, pretty much. And now, what we're gonna do with this matrix is by the different operations that we can do with this matrix. So if you're not familiar with the different operations that we could do to a matrix, what we can do is subtract one row. We could only mess with the rows. We can't do anything with the columns. But what we can do is for each row, if we wanted to, we could subtract, let's say row 1 by row 2. So that's one operation. If we want to, we can multiply a row by a scalar. So say if we wanted to divide row 2 by 2, we divide all these entries by 2. So that's another action that we can take. Or we could switch these. So if we wanted to, we're able to switch row 1 and row 2 just so that they're in a different position, pretty much. And the reason why we do this is that we want to get this matrix into what is called a reduced row echelon form matrix. And I'm gonna cut over to what a reduced row echelon form matrix looks like real quick. So here I have a few examples of what a reduced row echelon form matrix looks like. So there are 4 things that make up a reduced row echelon form matrix, and we're just gonna go over them really quick. So the first one is that all non-zero rows are gonna be above all the 0 rows. So pretty much we could see how all these rows are non-zero, and at the very bottom of each matrix consists of all 0 rows. So we could clearly see that with each of these matrices. This one, however, does not have one. The second quality is that for each leading entry of each row, so starting from left to right, it's always going to be a 1. So we could see that for this matrix, for example, we could see how all these leading entries are just going to be a 1. The same thing, we could also see the same thing for for the other matrices as well. So that's the second quality. For the third thing is that for each leading entry, on top of it and below it are going to be zeros. So for the column that the leading entry is in, it's always going to have zeros on top of it and below it. So we could clearly see that with this leading entry. Same thing for this one, we have zeros below it and on top of it. Same thing here, and then we could also see the same thing for the other matrices as well. And the fourth and final thing that make up these matrices is that for each leading entry, it's always going to be above and to the left of the leading entry that's below it. So we could see, if we were to take a look at this leading entry right here, we could see how it is above. It's above and to the left of the leading entry that's below it. We could also see that for this one, that it's on top and to the left of the leading entry that's below it. And we could almost kind of create like a staircase pattern. So starting from the top left, every time we encounter a 1, we go down a level. So we always get like this almost staircase pattern when trying to satisfy that condition. So those are the 4 things that make up a reduced row echelon form matrix. So here we have the original matrix that we were left with, and we're gonna try getting it into that reduced row echelon form by doing all those different transformations. So yeah, let's just get right into it. So we know for the reduced row echelon form matrix that every leading entry is going to be a 1. So we're gonna take this first row and we're gonna divide it by 3. So that way this first part becomes a 1. And we're gonna take this one step at a time. So we have a 1 there. Those are zeros. They're actually not that 0. So this one becomes a negative 1/3. And that one becomes a 0. And everything else is going to just stay the same. So we have all of this. Okay. So now that we have that, we also know for each of these, for the matrix that we're trying to get, that for each leading 1, on the top and bottom have to be zeros. So what we're gonna do to the second row is we're gonna subtract it by 2 of row 1. So that way we could just get rid of this 2 right here. When we do that, we then get the matrix, so the first row just stays the exact same. So we have that. And then we have 2 minus 2 times 1. That gives us 0. And this also stays as a 0. We have 0 minus 2 times negative 1/3. That's going to be 0 plus 2/3. So we have a 2/3 right there. And this negative 1 stays the same. And the rest of the matrix as well stays the exact same. 0, 1, negative 2, 0. Okay, so now we have our first column dealt with. So we have this leading entry, which is part of row 1, and we have this column all finished. So at this point, we don't want to mess with row 1. We just want to mess with these 3 right here. And what we could do from here is, because every leading entry is a 1, let's switch these 2 rows right here. So that way we could get this 1 right here. Again, we kind of want to make that staircase-like pattern. So we have the first row. It's going to stay the same. And we're switching these 2. So we have 0, 1, negative 2, 0. Row 3 stays the exact same. And this one turns into row 2. So 2/3 minus 1. Bam. Okay. So now what we can do at this point, because we want that 1 to be the only one of its column, we're going to subtract row 3 by 2 of row 2. When we do that, we now get the new matrix. So row 1 stays the same. And row 2 also stays the same. So now we have 0. So here we have 2 minus 2 times 1. That gives us the 0 that we want. Now we have negative 2 minus 2 times negative 2. So that becomes negative 2 plus 4. So that gives us a positive 2. And we have negative 3. That stays the same. And then row 4 stays the exact same. Okay. So now we have column 1 and column 2 done. And because these leading entries are part of row 1 and row 2, we can't mess with those rows anymore. So now we just have these two right here. What we could do from here is we need at least 1 as our leading entry for one of these. So what I'm gonna do is multiply, or not multiply, but divide row 2 by 2. When we do that, we then have 1, 0, negative 1 over 3. So rows 1 and 2 stay the exact same. And now for row 3, we have 0, 0, 1, negative 3 halves. We have 0, 0, 2 over 3, negative 1. Okay. And now we want this one to be the only leading one of its, to be the only one, I guess, only one value of its column. So what we're gonna do is we're gonna change all these rows. So we're gonna be doing a bunch of operations here. So for this first row, what we wanna do, because it's negative 1 over 3, we're gonna add 1/3 of row 3. And I'm just gonna get rid of this arrow for now. I'll draw it right here. For row 2, we wanna add 2 of row 3. And for row 4, we wanna subtract 2/3 of row 3. Now these are a lot of operations, so we're just gonna go by them one by one. Now notice how because these two values here are 0, these two first columns are gonna stay the exact same. So 0, 1, this just makes our job a little bit easier. And we just gotta make sure that for every other value of this column becomes 0. So negative 1 over 3 plus 1 over 3, that's 0. Negative 2 plus 2, that's 0. And 2 over thirds minus 2 over thirds, that's 0. So we have 0, 0, 1, 0. Okay, so now we gotta deal with this last row. And this is where the main thing happens, pretty much. So we have 0 plus 1 over third minus 3 halves. So I'm actually just gonna write this. So 0 plus 1 over third minus 3 halves. That gives us negative 1/2. All right. Then we have 0 plus 2 times negative 3 halves. That gives us negative 3. This value stays the same, 3 halves. And then for this last one, we have negative 1 minus 2 over thirds times negative 3 halves. That's negative 1. This would be plus 1, so we get left with a 0 at the bottom. So here is the reduced echelon, whatever form that we are trying to pursue. So now that we have the reduced row echelon form of this matrix, we pretty much have this on lock now. So what we're gonna do is turn this back into an equation. And the way we do that is recall that each of these columns corresponded to a letter. And also recall that each of the equations that we made equaled to 0. So when we turn each of these rows back into the equation, here for this first row, we get that A minus 1/2 D is gonna be equal to 0. We do the same thing for row 2. We get B minus 3D, that's gonna be equal to 0. Then for row 3, we have C minus 3 halves D, and that's gonna be equal to 0. Notice how for each of these equations, we have D in them. So what we can do is take D and put it to the right side of the equation. When we do that, we get A is equal to 1/2 D. We get B is equal to 3D. And we get C is equal to 3/2 D. Now, we want to choose, at this point, we want to choose a value for D in a way so that A, B, and C are whole numbers, because none of these can be fractions. So we want to make sure we choose a suitable value for D, so that way none of these become fractions. And by looking at these, we could choose D equal to 2. When we do that, we get that A. So when D is equal to 2, then A is equal to 1. And when D is equal to 2, B is going to be equal to 6. And when D is equal to 2, we get C is equal to D. And just like that, we have our coefficients for this chemical equation. So we could just plop them in, and we could just make sure if our answers are correct. So we have 1 right here. That's going to be 6 right here. And why did I write D there? So C, this is going to be 3. That's my bad on my part. So we have 3 there. And here we have a 2. Now let's just verify our answer real quick. So we can see here we have 3 bariums. Same thing for here, we have 3 bariums. So the bariums are good. We have 2 nitrogens, 2 nitrogens. That's perfect. And here we have 12 hydrogens. Right here we have 6 hydrogens. And right here we also have 6. So we have 12 and 12. That's good. And now we have 6 oxygens, and 2 times 3, that's also 6. So that's pretty much how you can use linear algebra, or use this matrix trick to solve for these chemical equations without having to guess and check for them. And yeah, hopefully you guys found this video helpful. And yeah, see you guys later.